Okay, so we're looking at question 7 in the heart. Right, so we now need to plot this data, a bar graph. So we need to put the year along the bottom. 1, 2, 3, 4, 5, 6. So there's 6. Let's have a look. 1, 2, 1, 2, 3, 4, 5, 6. Okay, that's good. And we go from 48 to 125. Whoa, 48 to 125. 48 to 125. So how much would that be? 48. That's 40. Just say, let's for argument's sake, 40, 50, 60, 70, 80, 90, 100. And we've got 135. So that's not enough. So what we need to do is maybe go up in 20s then. 40, 50, 60, 70, whoa, 80, 90, 100, 100, 20, 140, 25, 160. Nope. Let's not try that. Oh, what if we went 40, 50, 60, 70, 80, 90, 100, 110, 120. It goes to 135. So 130 and 140, that's more than enough. Right, we need to write that label. Number of, okay, so we need to write up here on the y-axis, number of heart attacks per year. Number of heart attacks per year per 100,000 people. Right, okay, let's not put year, that would cause confusion. Whoa. Whoa. Okay, let's try that. It doesn't like it. What's going on? What is wrong with this silly thing? Okay, per 100,000. Right, and what goes along the bottom we can put year. So we're going to stick 69 to 73. 69 to 73 there. We can stick 74 to 78, 79 to 83, 84 to 88, 89 to 93, 94 to 98. There you go. Now we just plot it. Right, so what we need to do, a bar chart. Right, let me see if I can get hold of that. Can I get hold of that? Oh, what a shame. No, something's gone wrong. What's gone wrong? Let's have a look. What's going on here? No, nothing's happening properly. Okay, no problem. What we'll do, we'll attempt don't know what's happened. Right, let's forget that for a second. I'm getting distracted. Right, let's plot the men. So we need 1, 2, 5. So I was gonna rub these lines off. 1, 2, 5 is there. So if I did men like this, and you're gonna obviously use a ruler because you're professionals. Right, 1, 2, 5. 1, 3, 5 for men here. 1, 3, 5. So it's halfway between there, and it goes down here. There you go. 116. Really? Did I just put that in the right place? Oh my god. 116. So there's 100, 110, 115, 116. So I'll go down here, and that would be right. What I need to do, if I can, right? Can I? No, can't. Can I? Right. What happened if I grab this? Good. So I've drew that in the wrong place because it's men and women. It's a double bar graph. Because they've actually asked for a bar graph, not a polygon. So 86. Now look, we've done. No, it's not going to behave, is it? We've done that. We've done that. We've done that. We're looking at 86. So we go to 86. Where is 80s there? 82, 84, 86. So I just do it. So hopefully these should be a bit shorter and easier. 86. We've done that. We do 68 now. 60's there. 60's there. 68 is there. Okay, and then you've got 94 is 48, so we're looking at 48 now. That's 48 is there. Right, so we can put the key there. Black is men, and let's do women as red. Right, we need 13. Whoa! So I've just done all that. Right. That's why you should never do that. So the heart attacks for women is so low, it's off here. So I need to move up 4 more. Do you know what I can do? I can cheat. I can go up 10, 20, 30, 40. Hey, technology. But you obviously won't be able to do that because you will not have a computer to mess about with. So let's draw it. "30, 20, 10 and 0. So now we can do the women's thing. It was 13 and 15. So 13 is so small. So we can do the women like this. We can shade theirs in. Right. 15. It's not there. Oh my God. It's here. 15. It's halfway along there. There you go. So we've done 13, 15. We do 11 now. 10, 11 is there. Halfway between. I can't draw straight. So we've done 13, 15, 11, 6, 9, and 9. So we do 6. So that's 2, 4, 6 there. And 9 and 9. So 9 is there. And 9 is there, just below 10. Half a square below. There you go. That was painful. Hey, but it's done. Right, we've done that. Describe how the data differs for men and women. So what happened was the men's data went up slightly and then it started going down, and the women's data was decreased slightly then increased. So you can say women, right, okay, let's write this properly. Women have much less heart attacks than men. There you go. Right, and we're gonna say that men's heart attacks went up and then they went down, and the women stayed pretty much the same. And you can then say women's heart attacks stayed the same, similar, right? Whilst men's heart attacks decreased. There was a slight increase, but generally a decrease. It went from about 139, well, yeah, over a half. It's a drop. They've changed their lifestyles. Explain the change in the number of heart attacks from 69. So there was a point where smoking became really bad. It was not cool anymore. So people gave up smoking and maybe drinking. They also did more exercise. Right. Explain why reducing the blood supply to the heart muscle cells can cause heart attack. So remember we said that's your heart, and it's a muscle, and every organ and every tissue needs a supply of blood, and the heart's got its own supply of blood via the coronary artery. Coronary artery. When that gets blocked up, you have less oxygenated blood. So that means more anaerobic respiration. What does this mean? More lactic acid buildup. What does this mean? That means that the enzymes are not working in optimum pH. So they're not working properly, and they could die. And then what that means is that the cells will die, causing heart attack. heart attack. So let's have a look. What you could add here is when the enzymes are not working at optimum pH, because the pH will, and also the any temperature, the pH will denature the enzymes. They'll stop working correctly. Right, okay, that's cool. Let's keep going. No. Okay, there you go. Right. You've got experiment to look at the exercise on heart rate. Children, both boys and girls. It was measured 3 times. At rest, just before exercise, and immediately after carrying out 1 minute of exercise. So you've got rest, 76, it goes up a bit just before, as you're getting excited, you're anticipating it, your adrenaline kicks in. And then straight after, because you've been running or exercising, your heart rate's higher to supply your cells with oxygen and any energy for respiration. Okay, calculate the average after exercise. So okay, so this is simple. So if you work out, right, you see the thing is there's an anomalous result. Which one is it? Which of them is 72, 72? It has to go up, 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 up. 82, 80, 90, 87, 92, 89, 98. Alright, this one here. So if you look carefully here, that one's gone down. So that's what you would call anomalous, and maybe you can find out why. But right, we need to do the mean for the kids that did exercise. So what you do is you add all these together and then you divide by, I would exclude that. I would add all these and then divide by how many students were there, did it say? It just says a group, so you count how many, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So you then divide it by 19. I would be inclined to do it that way. So the answer should be 136. Or the mark scheme says 136.1. Okay. So the anomalous result, anomalous just means away from the normal. It's not normal. It doesn't follow the trend. It was Thomas, wasn't it? Thomas, yeah. Suggests why the mean value of heart rate just before exercise is different. Because adrenaline is produced by the adrenal glands, is produced, so increases heart rate and breathing, ready for exercise. So what happens is you have more energy being provided for the muscles for aerobic respirations. For aerobic respiration. There's lots of things going on there. Okay, name 2 variables that should be controlled. Right, so remember we said there's 3 types of variable. independent variable. What else did we say? Dependent variable and a control variable. Right. Independent is the one that you change in a sort of controlled way. It's the variable that you change. It's the variable you change. Dependent variable is the one that you measure because of the change, and control variables are the variables you keep the same, right, to make sure the tests are fair. So for example, if you want to know going to the gym 3 times a week for a month, does it affect fitness? You don't want to choose 3 people that are obese, 3 people that are old, 3 people that are young, 3 people that are doing exercise regularly, because it doesn't give you an idea of whether the exercise changed or whether it's the people and what condition that they're in the first place. So you'd say, okay, I'm going to choose all males. They're going to be between 25 and 30, and they're going to all be have a BMI index of, I don't know, 35 or 45 or whatever it is, to keep it fair. You keep these variables the same. Anyway, let's move on. So what should we control? You should control the age of the people, the gender, the age, the gender, the fitness levels. Yeah, and what time of day that you're doing the experiments with the people. So there's loads of things that you could do. Let's move on. Long distance runners and cyclists have a lower than average resting heart rate. Why has it developed in these people? Right, okay. The heart is a muscle. So when training, it becomes stronger. So each heartbeat allows the heart to pump more blood. So less heartbeats, okay, let's use the word. So a lower heart rate is needed. Okay. Low heart rate needed to supply oxygen and nutrients for aerobic respiration. Remember, there's 2 types of respiration. Aerobic, that means with oxygen, that converts more of the glucose into energy that you need. And you have something called anaerobic respiration. All that means is there's not enough oxygen, glucose, some of it is turned into lactic, some of it's turned into lactic acid, and some of it is turned into energy. And then what happens later on, your body takes later on it will take the oxygen and turn that lactic acid back into energy. That's the oxygen debt. Your body still is owed that oxygen and it'll pick it up later. Right, let's move on. Right, we need to read this. Excess lipid, fat, oils in the human diet can increase the risk of health. However, a balanced diet, yep, and it goes all the way through all this. You can read this from there to there. It's talking about overfishing. Right, okay. So what they're doing is saying suggest how excess fats and oils can increase the rate of right. They will block up the coronary artery, which means, so that's your first point. Your next point is, which means less oxygen for aerobic respiration. So again, all these key words. So more anaerobic respiration occurs, meaning more lactic acid is produced. This can this can denature the enzymes and kill off the cells, leading to a heart attack. Okay, that's okay. Right, fats and oils are large insoluble molecules needed in a balanced diet. Give name of two small soluble molecules. So you could have glucose or sucrose. That means that it can be absorbed into the blood. You can have other molecules. You can have amino acids. You can have, what the molecules have you got? You've got just say for example vitamin C. You can have minerals, which is sodium chloride, salt. Right, state the function of lipid in a human body. Right, of lipid in a human. So you can say it is a store of energy. So when your body hasn't got long-term supply of energy, it can live off the fat reserves. It can act as insulation, and lipids can be used to make the myelin sheath on nerve cells, on neurons. Okay, so you say that's your nerve cell or part of it. Impulses travel up and down here. Impulses, which are electrical signals, and they're like wires. So you don't want wires touching each other; it'll cause a short circuit. So you have a myelin sheath. It's like a cover. Like a plastic cover. Anyway, let's move on. Fatty acids are one component of a lipid molecule. So the other one is glycerol. So look, lipid can be broken down into fatty acids and glycerol. It's good to know that. Anyway, so 30 minutes, come on. This is the last question. Right, okay, let's try to squeeze this one in. Right, blood comes in through the vena cava, C. This is the, remember we said that's the right hand side, that is the left hand side. So this is the right ventricle. It's so hard to see this. Right, okay. And the blood leaves via the aorta. Right, let's forget about that for a second. You can see roughly 4 chambers, but it's difficult in this diagram. Right, give the letters of the chambers where oxygenated blood is found. That's deoxygenated. So it is E. That is the pulmonary vein. No, pulmonary, yes, vein, sorry. And in the chambers, oh my god. They've not asked how does it get in. They've asked which chamber. Read the question. So it's the left atrium and the left ventricle. It's the left, it's E and F. Okay. Right, describe how the structure of the aorta is adapted for its role. Right. This is the aorta. Remember we said there's a vein and there's a artery. The aorta is the artery. We said the artery has a small, what did we call this hole in the middle? This hole in the middle. We called it a lumen. It has a small lumen and it has a thick muscular wall. Right, the lumen is the hole inside. Right. So it has a thick muscular wall that allows it to withstand. It can handle the high pressure, high blood pressure, and return it back to its original shape. So it does a few things. Right, what they've also added here is, let's go. So here, as the blood is leaving the chamber, it has a valve to prevent backflow. So it also has a valve at the start, yeah, not inside it, to prevent backflow. Okay, that's fair enough, but these would have got you 3 marks. And the maximum you're allowed is 2, so you could have used any of these. Right, right, there you go. The table shows 3 blood vessels: aorta, capillary, vena cava. Remember, vena cava or cava. Remember what we said, capillaries. What do? What do capillaries do? They take blood into organs, so they have to be very, very fine, very fine. 1 cell thick. So then there's a short thick, right? So there's a short diffusion distance. I like distance. It makes more sense to me, but people also call it pathway. That might be more of a correct term. Right. Blood has to travel 20 centimeters from a person's heart to the renal artery. Calculate the time taken for the blood to flow. So speed equals distance divided by time. Distance divided by time. So they said the speed is to their renal artery. So it starts there. It's traveling at 40. So we know the speed is 40. And the distance is 20 centimeters. And remember, this is centimeters per second, not meter or kilometer. So, and we divide it by time. Now we need to rearrange this. And this is where students mess up. If it's at the bottom, just swap that with that. So I'm going to end up with time equals 20 divided by 40. And that is, we cross them out. So it's 2 divided by 4. We can cross that out. That's a half. It takes half a second. Alright, explain how the speed of blood flow in a lung capillary affects the gas exchange. So have you noticed the flow is really slow? So slow flow means there's more chance or more diffusion takes place. More diffusion takes place. And then you can put, right, because it's talking about the lung, so that means CO2, carbon dioxide out of the blood and oxygen into the blood. That would get you to 2 marks. Right, okay, that's it. That was a long video, but inshallah it'll be useful for you.